We're here at Glenn Research Center in the Exercise Countermeasures Lab. Gail Perusek joins me now. She is the project manager for Advanced Exercise Concepts for the Human Research Program. And Gail, we have a lot of concepts around us, a lot of real things that are used on the space station right now. Tell us about what you do in this lab.
Sure. The Exercise Countermeasures Lab is a place where we can test, develop new equipment for astronauts in the area of exercise countermeasures in a realistic environment here on Earth. So we're developing new equipment, new sensor technology, new protocols to improve the exercise countermeasures, hardware and routines that the astronauts use to stay healthy in zero gravity and mitigate the bone and muscle loss that we see when they don't get adequate exercise.
And we really don't think about it, but exercise is a lot different in space. Well, maybe not a lot different, but there are things you have to do differently because nothing to weight you down, right?
That's true. Yeah, that's true. So the equipment that we've got on Space Station now, we've got an advanced resistive exercise device, which is a lot like lifting free weights, but in zero gravity. It uses a principle of vacuum cylinders and flywheels to provide that resistive load. We've got a cycle ergometer with vibration isolation system, and that's a lot like a stationary bike for an aerobic workout. And then there's the second generation treadmill, or T2, which is basically a commercial treadmill that's been fitted to a space station rack, again with a vibration isolation system. And as opposed to a treadmill at the gym where you just jump on and go, the crew members don a harness and they tether themselves down to the treadmill with a set of bungees or a subject load system. And that allows them to generate the forces under their feet to get that impact loading that's so important for bone health, and allows them to get a good workout.
So is that something like we see here, or is this something new?
Exactly. So this treadmill. Now this one has an acronym and it's a mouthful, but
they all are.
Yeah, we call this the EZLS, or Enhanced Zero Gravity Locomotion Simulator. We can simulate the ISS treadmill, and some of the unique things about this system is that we can actually float this on a film of air, on air bearings, so it reacts to the footfalls of our human test subjects, our human volunteers that we appreciate so much. So we can really get a good simulation of what the loading regime, what the exercise prescriptions are really doing from from an engineering perspective in terms of loading into the vehicle, loading into the body. So it's a great simulation, a great analog for developing new equipment. So one of the success stories to come out of this lab is a new, more ergonomic, more comfortable treadmill harness that was developed with our collaborators at the Cleveland Clinic. And the crew members were coming back from the expeditions with complaints of the previous harness design of causing discomfort. And so we worked with the clinic and our engineering teams here at Glenn and at Johnson Space Center to develop a new and better design. So that design was tested here in the simulator, and it was flown in about 2009, 2010. It was met with great feedback from the crew, and we transitioned to operations, and now the crew members each get a what's called a Glenn harness, and that was developed right here.
So also with the success stories, we want to talk about how these exercise countermeasures, everything they do is really helping them now. At first you didn't know a lot about what was causing bone loss and muscle loss, and now they exercise 2 plus hours a day?
2+ hours a day, 6 days a week. We are definitely learning more about the optimal regimen, the optimal equipment, what the exercise hardware needs to do in terms of providing optimal force characteristics, if you will. The ARED, the new Advanced Resistive Exercise Device, which was flown on station in 2008, provides a 600-pound resistive force The previous IRED, or interim resistive exercise device, was limited to 300 pounds. And since the ARED has flown, we've seen crew members come back healthier than ever. So we are taking that capability and we're benchmarking it for our next generation designs for missions to Mars, Mars transit, these long duration missions. All of that is being taken, and the ultimate, well, the goal for towards the end of the decade for space station is to bring that all together in an integrated, optimized countermeasure suite, which will be our best designs, our best efforts for the Mars mission.
We're all counting on you. Thank you, Gail, for showing us around.
Thank you.